Imagine a star that isn't made of ordinary matter. A star that doesn't shine by the nuclear fusion process we're all familiar with. What if I told you that in the vastness of space, there could be a mysterious class of stars that defies everything we think we know about how the universe works? Enter the enigmatic Boson stars, objects so strange and fascinating they could hold the key to unlocking some of the universe's most cryptic mysteries. These stars could be the missing piece that helps us understand dark matter, quantum gravity, and even the fundamental laws of physics. Are they just a theoretical fantasy? Or could these quantum giants truly exist, hidden in the far reaches of space? Boson stars are a theoretical type of astronomical object, predicted by physicists as a possible outcome of a unique class of particles known as bosons. Unlike the ordinary matter we know, which is composed of fermions like protons and electrons, bosons behave quite differently. They don't obey the same exclusion principle that fermions do, meaning that multiple bosons can exist in the same quantum state. This unusual property might enable the formation of strange and exotic objects in the universe, such as boson stars. But what exactly would these stars look like, and how would they differ from the stars we see every night? Boson stars wouldn't shine in the traditional sense like the Sun or other stars we're familiar with. Instead of relying on nuclear fusion to generate light and energy, boson stars are theorized to shine in a completely different way, if they shine at all. These stars are composed entirely of hypothetical particles like axions, which are predicted to be ultra-light and incredibly stable. These particles, if they exist, could clump together under gravity and form dense, star-like objects without undergoing fusion. What's even more intriguing is the fact that these stars could be invisible to most of our current telescopes. Boson stars would likely emit little to no electromagnetic radiation, making them nearly impossible to detect through conventional methods. However, their gravitational effects might still be detectable, leading some scientists to suggest that they could potentially be a form of dark matter. Dark matter itself is an invisible substance that makes up a large portion of the universe's mass, but remains undetectable by normal means. Could it be that these mysterious boson stars are the key to solving the riddle of dark matter? The very idea of a star made of quantum particles that doesn't shine like traditional stars, and could potentially be a dark matter candidate, is mind-blowing. It challenges our current understanding of astrophysics, gravitation, and the very nature of the cosmos. The formation of boson stars is one of the most fascinating aspects of their theoretical existence. Unlike regular stars that form from the collapse of hydrogen gas into dense cores that ignite nuclear fusion, boson stars are born through a very different mechanism. To understand how they form, we first need to dive into quantum mechanics, a realm of physics that governs the behavior of the smallest particles in the universe. Boson stars are theorized to emerge when a collection of bosons, particles such as axions, collapse under their own gravity. However, instead of collapsing into a singularity like a black hole, these particles remain in a delicate quantum state that prevents them from collapsing further. In a process known as Bose-Einstein condensation, a group of bosons can condense into a single quantum state, behaving as if they are all in the same place at the same time. This effect creates a stable macroscopic quantum object that could potentially exist as a star. The challenge with understanding this process is that it defies the classical notions of how gravitational collapse works. In regular stars, gravity causes the matter to contract until the pressure from nuclear fusion balances out the gravitational pull. In the case of a boson star, there's no nuclear fusion to counteract the gravitational pull. Instead, the quantum effects of the bosons themselves provide the necessary pressure to prevent collapse, creating a delicate equilibrium that allows these strange objects to exist. These stars would be incredibly dense, likely much more so than ordinary stars, yet stable due to the quantum forces at play. Their formation requires very specific conditions that are hard to replicate or observe, and because they don't emit traditional light, they would likely go unnoticed by most telescopes. This raises an important question. Could we be surrounded by these mysterious quantum stars, unaware of their presence, as they exist in the dark corners of the universe? One of the most intriguing aspects of boson stars is their potential connection to dark matter. Dark matter is an invisible substance that makes up around 27% of the universe's total mass. Yet it doesn't emit, absorb, or reflect light, making it completely undetectable by traditional means. We can only observe the effects of dark matter through its gravitational influence on visible matter, like stars and galaxies. But despite extensive efforts, we have yet to directly detect dark matter. Some physicists have speculated that boson stars could be a form of dark matter. The reasoning is quite compelling. If bosons like axions exist in the right conditions, they could form dense, star-like objects that don't emit light, much like dark matter itself. These boson stars could account for some of the missing mass in the universe. But are boson stars just a theoretical construct, or could they actually be out there, hiding in plain sight? The connection between boson stars and dark matter opens up new possibilities for understanding both phenomena. If boson stars are real, they could serve as a bridge between the quantum world and the cosmic one, providing valuable insight into how dark matter behaves and how it interacts with regular matter. It's a tantalizing idea that could revolutionize our understanding of both particle physics and cosmology. But how can we detect these elusive stars? Could we ever gather enough evidence to prove their existence? These questions are at the forefront of the scientific community's exploration of both boson stars and dark matter. The hunt for boson stars could unlock a treasure trove of information about the universe's most mysterious substances. At the heart of the boson star concept lies the axion, an extremely light hypothetical particle that could be the key to understanding both dark matter and boson stars. The axion was first proposed in the 1970s as a solution to a problem in particle physics known as the strong CP problem, which relates to the symmetry of the strong nuclear force. However, over time, scientists began to realize that axions might also be responsible for the elusive dark matter that's been theorized to make up most of the mass in the universe. In the context of boson stars, axions are thought to be the building blocks that could clump together under gravity to form dense objects. These axion clouds could then collapse into stable boson stars, without any need for traditional nuclear processes. What makes axions so intriguing is that they're incredibly weakly interacting with ordinary matter, meaning they wouldn't be detectable by most forms of radiation. But their gravitational effects could still have a profound impact on the surrounding space-time, offering a potential method of detection. The search for axions and boson stars is tightly intertwined. If we could detect axions in the lab or in space, it could confirm the existence of boson stars and help us unlock the secrets of dark matter. But axions are so difficult to detect that the search remains a challenging, ongoing pursuit. The discovery of axions could lead to groundbreaking insights into the nature of both dark matter and the universe itself. Could axions really exist, and could they form the boson stars that might be scattered across the cosmos? Scientists are actively searching for evidence of axions using a variety of innovative techniques, from laboratory experiments to space-based telescopes. The potential discovery of these particles could be a game-changer for both particle physics and cosmology. As we continue to probe the universe, one of the most exciting recent developments in astrophysics has been the detection of gravitational waves. Ripples in space-time caused by the acceleration of massive objects, like colliding black holes or neutron stars. These waves offer a unique way to study cosmic phenomena that are otherwise invisible to traditional telescopes. But could gravitational waves also help us detect the presence of boson stars? Boson stars, if they exist, would exert gravitational forces just like any other massive object in the universe. And because of their unique properties, they could potentially produce gravitational waves as well. If two boson stars were to collide or merge, it could create ripples in space-time that could be detectable by gravitational wave observatories like LIGO and Virgo. While we've yet to detect gravitational waves from boson stars, this possibility remains an exciting avenue for future research. The detection of gravitational waves from boson stars would not only confirm their existence, but also provide valuable data about their properties, such as their mass, density, and the type of particles they're made of. Gravitational wave astronomy has already revolutionized our understanding of the universe, and the discovery of signals from boson stars would mark a new era in our ability to probe the cosmos. Could gravitational waves be the key to finally detecting these mysterious quantum objects? It's a tantalizing possibility, and scientists are keeping a close eye on the data as they search for any sign of these elusive stars. Gravity, the force that governs everything in the cosmos, has always been a central part of our understanding of the universe. It's the force that shapes stars, planets, galaxies, and even the fabric of space-time itself. But when it comes to objects like Boson stars, gravity might not behave the way we expect it to. These quantum objects could force us to reconsider some of our most fundamental theories of gravity. In classical physics, we understand gravity through Newton's laws and Einstein's general theory of relativity. These laws work well on large scales, explaining the motion of planets, stars, and galaxies. However, when we look at extremely small or highly energetic objects like black holes or potentially Boson stars, general relativity starts to break down. What if Boson stars, with their exotic quantum nature, are the bridge that connects general relativity to the still unfinished theory of quantum gravity? Quantum gravity is one of the most elusive and mysterious areas of physics. It's the search for a single theory that can unify the quantum mechanics of subatomic particles with the gravitational forces that govern large-scale structures like galaxies and black holes. So far, scientists haven't been able to find a complete theory that works for both realms simultaneously. But could the study of Boson stars offer crucial insights into this quest? If Boson stars exist and can be observed, their properties might provide us with the missing piece needed to understand how gravity operates on the quantum level. For instance, because Boson stars are made up of quantum particles that behave differently from normal matter, they could exhibit gravitational effects that we've never observed before. Their mass could warp space-time in unusual ways, creating gravitational waves or phenomena that challenge our conventional understanding. The more we learn about Boson stars, the more we could unravel the mysteries of gravity itself. Could Boson stars help us finally unite the theories of general relativity and quantum mechanics? It's an intriguing possibility, and the discovery of such stars might mark a monumental breakthrough in our understanding of the cosmos. Since Boson stars do not emit light or traditional radiation, detecting them is no easy task. They are, by their very nature, elusive and invisible to conventional methods of astronomical observation. So, how can we even begin to find these mysterious objects scattered across the universe? One promising method of detecting Boson stars could lie in their gravitational effects on nearby matter. Just like how black holes warp space-time and influence the motion of stars and gas clouds, Boson stars might create subtle but detectable gravitational forces on objects around them. If we can observe these gravitational effects, for example by tracking the motion of nearby stars or gas clouds, we might be able to infer the presence of a Boson star. Another potential detection method could come from the gravitational waves produced by collisions or mergers of Boson stars. While these events might be rare, the immense energy released during such events could create gravitational waves strong enough to be detected by observatories like LIGO or Virgo. Scientists are already on the lookout for signals that could indicate the existence of Boson stars, but since these objects are so different from what we typically look for, it's a challenge to know exactly what to look for. Additionally, some researchers are investigating how the presence of Boson stars might affect the cosmic microwave background, the faint radiation left over from the Big Bang. Any subtle influence that Boson stars have on the cosmic microwave background could potentially be detected through sensitive instruments. The hunt for Boson stars is still in its early stages, but as technology advances, so does our ability to detect these strange quantum objects. Could we be on the cusp of discovering the first evidence of Boson stars? Only time and cutting-edge scientific techniques will tell, but the search is already underway. The existence of Boson stars might not only have implications for our understanding of dark matter, gravity, and quantum mechanics, but they could also offer insight into the formation and evolution of galaxies. Galaxies, with their billions of stars and vast interstellar gases, are the building blocks of the universe. Yet we don't fully understand how they form or why they evolve the way they do. Could Boson stars play a role in galaxy formation? Some scientists believe that Boson stars could provide a foundation of dark matter within galaxies, influencing their structure and evolution. If Boson stars are indeed a form of dark matter, their gravitational pull could help bind galaxies together and prevent them from flying apart. Without this unseen mass, galaxies could lack the gravitational stability needed to hold them together. Boson stars might also play a role in the formation of supermassive black holes, which sit at the center of most galaxies. These massive objects are thought to form from the collapse of gas clouds or the merging of smaller black holes, but the exact mechanisms are still unclear. If boson stars are present in the centers of galaxies, their interactions could influence the formation of black holes or even provide the mass needed to kickstart their creation. In fact, the very presence of boson stars could help answer some of the biggest questions about galaxy formation and evolution. If these quantum objects do exist in large numbers, they could play a significant role in shaping the galaxies we see today. Their gravitational effects might influence star formation, the distribution of matter, and even the evolution of supermassive black holes. Could boson stars be the hidden architects of galaxies, shaping the very structure of the universe itself? The discovery of these objects could provide answers to some of the most fundamental questions in cosmology. As we delve deeper into the mysteries of the universe, the study of boson stars presents one of the most exciting frontiers in modern astrophysics. But what does the future of boson star research look like, and how can we continue to explore these quantum giants? In the coming years, we can expect significant advancements in both theoretical and observational methods. Theoretical models of boson stars will become more refined as physicists continue to probe the underlying principles of quantum mechanics, general relativity, and dark matter. With advancements in quantum computing and simulations, we might be able to test these models in new and powerful ways. On the observational front, the development of more advanced space telescopes and gravitational wave detectors will increase our ability to search for these elusive objects. Instruments like the James Webb Space Telescope and future gravitational wave observatories could provide the tools needed to detect the faint gravitational effects of boson stars, potentially bringing us closer to confirming their existence. Additionally, the study of black holes, dark matter, and other exotic objects will continue to intersect with the study of boson stars. As we uncover more about the nature of space-time and the quantum world, boson stars could become a critical piece in the larger puzzle of how the universe works. The future is bright for boson star research, and we may be on the brink of one of the most groundbreaking discoveries in physics. Will we soon uncover the truth behind these mysterious quantum objects? Only time will tell. One of the most mind-boggling possibilities that boson stars present is their potential connection to parallel universes or alternate realities. While this may sound like something straight out of science fiction, it's a concept that has fascinated physicists for years, particularly those who explore the multiverse theory. The idea of parallel universes suggests that our universe might not be the only one. Instead, there could be countless other universes, each with its own set of physical laws, constants, and even versions of ourselves. If boson stars are indeed quantum objects that bridge the gap between the macroscopic world of general relativity and the microscopic realm of quantum mechanics, could they somehow act as portals or windows into these alternate realities? Theoretical physicists have long speculated about the existence of wormholes, hypothetical passages through space-time that could connect distant parts of the universe or even different universes altogether. Some theories suggest that exotic matter like the type that makes up boson stars might be able to stabilize these wormholes, allowing them to remain open long enough to allow something to pass through. If boson stars have properties that are both strange and otherworldly, they might hold the key to unlocking this gateway between universes. While the notion of traveling to a parallel universe may seem far-fetched, the study of boson stars could push the boundaries of our understanding in ways we cannot yet imagine. The strange, quantum nature of these objects might provide a new framework for exploring the very fabric of reality itself. Could they be the bridge that connects our universe to others in the multiverse? Could they help us answer the question of whether we're truly alone in this vast cosmos? Exploring these mind-blowing possibilities might seem like science fiction, but with every new discovery, we're inching closer to unraveling the mysteries of the universe. If boson stars can challenge our perception of reality, they could very well become the key to understanding parallel worlds. Dark matter is one of the most perplexing and elusive mysteries of the universe. Scientists are certain it exists because of its gravitational effects on galaxies and clusters of galaxies, but they can't directly detect it. Dark matter doesn't emit, absorb, or reflect light, making it invisible to our most advanced telescopes. So how do we know it's out there? Well, we know dark matter's influence because galaxies and galaxy clusters behave as though there is more mass in the universe than we can see with our eyes or instruments. This is where boson stars come into play. Some theorists propose that boson stars could be made of a type of matter that behaves like dark matter. These quantum stars, formed from bosons, particles that obey Bose-Einstein statistics, might offer a new way to understand the elusive dark matter that pervades the universe. Boson stars could be composed of dark bosons, hypothetical particles that have been proposed as a candidate for dark matter. These dark bosons are unique in that they could clump together under their own gravity to form a star-like object, but unlike regular stars made of atoms, they wouldn't emit light or radiation. Instead, they would interact with normal matter gravitationally, providing the invisible mass that we've been unable to identify. The idea that boson stars could be a manifestation of dark matter is incredibly exciting because it would finally give us a tangible object to study. Instead of merely hypothesizing about dark matter, we might be able to detect boson stars through their gravitational effects, providing a direct link between the unseen, mysterious matter and the stars, galaxies, and other objects we can observe. Imagine being able to study an actual boson star, measuring its properties and interactions with surrounding matter. This could allow us to better understand the nature of dark matter, which has been one of the most significant gaps in our understanding of the universe. If boson stars are indeed the dark matter we've been searching for, they could revolutionize our approach to the cosmos and lead to breakthroughs in both astrophysics and particle physics. As we look further into the mysteries of the universe, boson stars might hold the key to unlocking one of the greatest enigmas in science. Could these strange quantum objects finally explain the nature of dark matter and its role in the formation and structure of the universe? Only time and further research will tell. Boson stars are more than just a curiosity. They could be the key to unlocking some of the most profound mysteries of the universe. From their potential connection to dark matter to their ability to reshape our understanding of gravity and quantum mechanics, boson stars challenge everything we thought we knew about how the cosmos works. Their discovery would not only reshape our understanding of stars, but could revolutionize our understanding of the universe itself. By investigating these strange quantum objects, we might uncover new truths about the fundamental forces of nature, the origins of galaxies, and the nature of dark matter. The very existence of boson stars could mark a new chapter in the story of the cosmos, one that we're only beginning to understand. If boson stars exist, they could help us answer some of the biggest questions in astrophysics and potentially solve some of the greatest mysteries of the universe. Whether it's through their connection to dark matter, their role in galaxy formation, or their ability to challenge our theories of gravity, these quantum objects could change the way we look at the cosmos forever. But the search for boson stars is just beginning. As our technology and understanding continue to grow, the truth about these mysterious objects might be closer than we think. So stay tuned and keep looking up, because the universe is full of surprises, and boson stars could be one of its most exciting secrets. Boson stars are truly some of the most mysterious objects in the universe, and the more we learn, the more we realize just how much we still have to discover. What do you think? Could boson stars be hiding in the vastness of space, waiting to be discovered? Let me know your thoughts in the comments. Don't forget to like, share, and subscribe for more exciting cosmic discoveries, and hit the bell icon so you never miss an update. The journey into the unknown has only just begun, and you're a part of it.